Okay guys, so this is an example of from 4.7. I'm going to do something that is cubed when m is cubed. So the first thing you want to do is, because it has, the matching x cubed with the third derivative and then x with the first derivative, we could use this method where we're making y equal to x to the m. So as you do your derivatives, here you'll get mx to the m minus 1, m times m minus 1, x to the m minus 2, and then the third derivative would be m minus 1, m minus 2, x to the m minus 3. Okay, so then now let's plug everything in for our derivatives, right? So you'll have x cubed, and then this whole thing plus x times the first derivative, and then minus the function x to the m equals 0. So now, when we factor out the x to the m, you can see a couple things will cancel, right? That cubed cancels here, right? The 1 cancels with the x, and so what you'll have is m minus 1, m minus 2, plus m minus 1. Okay, so then here we're just really solving this. Set that to 0, because if we could find m, then we'll know what m would be there as well. So you don't really have to worry about the x to the m. So here I'm going to just distribute. I'll get m cubed minus 3m plus 2m. So this is m squared, sorry. And then plus m minus 1, right? So let's simplify. And then just to go over how to solve this is the fundamental theorem of algebra. So what you could always do is take factors of the constant over the leading coefficient, but this one's nice because that leading coefficient is 1. So you really just want to check plus or minus 1. You could use a graphing calculator, see where the zeros are. You're looking for zeros or x-intercepts. Or you could just start picking numbers that are factors of those two. So 1 would be a nice one, and then you're just doing synthetic. So if you notice all the coefficients for synthetic, I mean, you could do long division. I just find this to be quicker. And the way it works is this comes down, always the first one comes down, you multiply 1 times 1, and then this goes up here, and then you add, and then you repeat that process. So you multiply 1 times negative 2, and then you add 3 minus 2, okay, and then same thing. Oh, don't forget your negative for that last one, and then this should always wind up being 0 if you do that correctly. Once you get to this step, then because we use division, right, you decrease the power by 1, or the degree by 1, and now your new coefficients are 1, negative 2, 1, so it's going to look like m squared minus 2m plus 1 equals 0, and now we solve this, which is m minus 1 squared, or m minus 1 and m minus 1. So you can see that the number we first picked over here, m, right, equals 1, really now with this whole thing to be factored, you actually have m minus 1 cubed as your solution to finding the factors there, and then you could see that m equals 1 repeats. Now when they repeat, now this goes 3 times, so the way that'll work is when you write your solution, it's going to be y equals c1 x to the first, so that's the easy one, and then c2 x ln x, like I went over on the one video, and I know I didn't show this, but then it was c3 x, and then you just square that third m, right? M equal 1, this repeats, so you need to have the ln for the first one, well, nothing for the first one, so it's c1x, and then multiplied by ln x on the second one. And then every time after that, you just continue to multiply by ln x, so this is ln squared x. Alright, so I hope that helps with anything that winds up m to be cubed. And then you also have here the repeating factors.